All right, welcome back, geometry students. Mrs. Fellon. I am actually going to start with lesson 7.2 on page 202 of your student journals. All right, so we're going to chat a little bit about, there's a lot of like vocab and properties that we're going to talk about today. So what we're going to talk about are parallelograms. So first and foremost, we need to know what a parallelogram is. And so it is a quadrilateral. So remember, a quadrilateral is just a four-sided figure. And then what makes this one different is it has both pairs of opposite sides parallel. So obviously this is why it's called a parallelogram, right? Because opposite sides are parallel. And so if we could kind of draw like a little diagram, this is kind of what a normal parallelogram might look like. And so what you know is that opposite sides are parallel. So let's mark them as parallel with our arrows. And what's important that you understand here is that this is the definition. And so we're going to talk a lot about properties of parallelograms, but the definition of a parallelogram is the definition of a parallelogram just basically means a quadrilateral with opposites parallel. And so just kind of make sure that you kind of keep that straight as we kind of go through. All right, so there are several different properties that we're going to walk through. And so I'm just going to kind of explain them mostly. And then we're going to do a lot more practice like with a lot of these properties in class. All right, so anyway, a parallelogram opposite sides theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So the big thing here is that a property of a parallelogram is that opposite sides are congruent. And so remember, there are a lot of different types of parallelograms. And in this unit, we're going to talk about several different kinds of parallelograms. And so what's going to be really important is that we understand is that with any kind of parallelogram, whether we're talking about a rectangle, a square, a rhombus, opposite sides are always going to be congruent. And so that's what this theorem is stating. When we talk about proofs, one of the things you're going to maybe mention in here is they're going to call this the parallelogram opposite side theorem or something similar to that. You would not use definition of parallelogram if you're talking about opposite sides being congruent. So when you're doing proofs is going to be kind of where we need to get all of this stuff kind of straight in our heads. So if you're saying in a proof that opposite sides are parallel, then it would be because of the definition. If you're saying that opposite sides are congruent, it's because of this particular theorem. All right, so say on the same lines, parallelogram, basically we're talking about opposite angles being congruent. So if a quadrilateral is a parallelogram, then its opposite angles are congruent. So in addition, having its opposite sides are congruent, opposite angles are congruent. And again, you can kind of see here that they're marked with the same markings, and here they're marked with the same markings. And so again, just kind of keep that straight. So if you're going to be using a proof and you're stating that opposite angles are congruent because it's a parallelogram, it would be because of this theorem, the parallelogram opposite angles theorem. All right, let's go. There's a couple more properties let's chat about. So in 7.5, says parallelogram consecutive angles theorem. So what this one basically is saying is that our consecutive angles are supplementary. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So again, if you add up x and y, they're going to add up to 180. You can look at like consecutive just means they're in a row, right? Any two angles that are in a row. So those two, these two, these two. And so consecutive or angles that are in a row are supplementary. And so remember, supplementary is a vocab word we've used quite a bit, but remember it adds up to, so adds to 180 degrees is what we have to remember about that one. Again, if this was going to be used in a proof and you're stating that consecutive angles are supplementary, this is because of this particular theorem. All right, one of the last properties that we're going to talk about are going to be our diagonals theorem. And so in this particular theorem, it says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So what's important here is that you understand is that the segments are being bisected. And so there's going to be a couple different properties for other types of parallelograms that we're going to talk about angles being congruent, or excuse me, angles, the diagonals bisecting angles. In this particular one, we're talking about the diagonals are bisecting each other, which means that like this piece here is equal to this piece, and then likewise this piece is equal to that piece. So again, the diagonals, so I'll just kind of bisect each other. And so again, that's going to be one that kind of comes up quite a bit, because we're going to be kind of looking at those properties kind of definitely within the realm of proofs. And so we're going to want to make sure that if we understand, or if we know that the diagonals are bisecting each other, then that is the rationale would be because of this particular theorem. All right, so that's all I'm going to do for this particular video. What I'm going to ask that you do is kind of try some of the extra practice. We're going to be doing it in class, and so you're going to be kind of working together through that in your classes. I would also encourage you, obviously, to try some of the stuff on big ideas in some of the practice that we have posted, and then, of course, as always, come to class with any questions. Thanks, guys. Bye for now.